Hello, and today's learning target is I can write an equation in slope-intercept form from a graph. Today we are going to write a linear equation from a graph. Let's review what slope-intercept form is. So if you can recall from previous lessons, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So if you can also remember how we find slope is rise over run, and then B, the y-intercept, is where the line crosses at the y-axis. That would be called the y-intercept. And to help you remember which axis is the y-axis, sometimes students say y to the sky because that axis is the one that's going straight up and down. So, in order to write a linear equation, we will need to find the slope and the y-intercept. So, let's take a look here at an example. So, I need to write an equation given this graph. So I need to locate 2 points that are on this line that actually cross at spots where the grid point is. So if you see I already have a red dot at 3. I'm also going to put a dot right about there at -2. Now I'm going to go ahead and count the slope. So rise over run. So I go up 1, 2, 3. I could actually probably draw a straight line and count 3 and then run 2. So here my m is 3 over 2. Now my y-intercept, and just for reference for today, I'm going to highlight the y-axis so we can see this. So here again, the straight up and down axis is the y-axis. In red, I already have highlighted where the y-intercept is, and that value is at 3. So the y-intercept is 3. So if we can recall, again, y equals mx plus b would be the slope-intercept form for a linear equation. Now I'm going to plug in what I really have for m, which is 3/2 x, and then what I really have for b here, which is 3. So my linear equation for this graph would be y equals 3/2 x plus 3. Okay, let's look at the next example. So here with this graph, I see that it's going downward from left to right. So as you remember from before learning about slope, this will have a negative slope. But to confirm that, let's go ahead and check that. So I have a point already, a red point, and I'm going to make another point here where my graph crosses a grid line, and I'll put that right there. So I'm going to go down 1, 2, 3, 4, 5, right? And then over 1. So if I go down 5, that's a -5, and I go to the right, +1. So my slope is -5 over 1. But really, what that turns into is we don't even need the over 1 when we write our equation. We know that when we actually were to graph that, we'd go over 1 unit to the right. But here, I can just simplify that to -5. And then I see with that red dot where that crosses the y-axis. And again, if this helps you to remember which one's the y-axis and where it crosses, highlight that axis, and where that crosses is at -3. So m here is -3. So when I write my equation, I have y equals -5x, and then because I'm just subtracting 3, or the y-intercept is a -3, I don't need to add anything here. I can just say -3. And that would be my equation in slope-intercept form for this graph. All right, let's look at a few more examples. Okay, so here I can see 1 point on the line, and I'll make another point where my line crosses the grid line right there. So now if I figure out my slope, I will go down 2 to the right 1. I know it's kind of difficult to see that. Maybe I can change colors. There's my path that I've taken. So m equals, let's do -2 over 1, which really equals -2. Now, as you notice on this line, there are multiple ways you could figure out what points to use. Like here, I'll highlight in green would be another point, right? So if I wanted to find the path between, let's say, the red and the green point, I could go down this, down 4 units and over 2, which 4 over -2 is still -2. So it shouldn't matter which 2 points you choose that are actually on the line that cross the coordinate plane. You should still get the same slope if you complete that correctly. So we got our slope of -2, okay, and then the y-intercept where that line crosses the y-axis, here is 2. So when I put this together, I get y equals -2x plus 2. And that would be the equation for this line, for this graph. All right, moving to the next example. Okay, so I already have one point on the graph. I'm going to go ahead and make another. So, I don't even have to use my y-intercept if I don't want to, but I can. So I'll use, let's go back to the marker. I'll go to this point right here, and then I go up 1 unit over 2. So my slope here is 1/2. My y-intercept, as you can see the red dot where it crosses that y-axis, is a +3. So now putting my equation into slope-intercept form, again remember y equals mx plus b. Y equals 1/2 x plus 3 would be the equation for this graph. Okay, so now let's continue here. I have 1 point on my graph. I'll go ahead and make another. So I'll choose this point right here. So now I can start at either point. I'll start at the top point, and I'll go down 2 units and over 3. So my slope gives me, or is -2/3, and my y-intercept is -2. So as I write this into slope-intercept form, y equals -2/3 x minus 2. Okay, let's continue on. All right, so for this example, we see a flat line. And if you did not remember that the slope here is 0, that's okay. We can still figure out the slope in this equation, or this line of the line, by figuring out 2 points. So if I choose this point here and maybe this point here, I rise 0, right? I don't go up or down anything, but then I run here 2. So my slope would be 0 over 2. And that simplifies to 0. And if you don't remember that 0 divided by any number is 0, double check it on your calculator, right? It will tell you 0 divided by 2 is 0. All right, now my y-intercept. Where does this cross the y-axis? Well, right there it does, and that's at -2, so my y-intercept is at -2. So if I write this equation in slope-intercept form, I would write y equals 0x minus 2. And if I simplify it a little bit further, because you don't even need to write 0x, I get y equals -2. And that's my equation for this line. Again, when you have a flat horizontal line, your slope is always 0, so you don't even need to write any x variable because we know 0 times x is just 0. All right, now let's take a look at the last example. Now with this example, we see kind of the opposite. Before we saw a horizontal line, now we see a vertical line. So if you look, your value, or that line, is at a value of -2 on the x-axis. So it doesn't matter what y will be, x will always be -2. So when you have a straight up and down line, wherever that value of that line is what x will be equal to. And it doesn't cross the y-axis at all, so, it doesn't matter what we plug in for y, we would just get x equals -2. Therefore, that's how we'll write the equation for a vertical line. Just as how you saw for a horizontal line, and we check that also by finding the slope and knowing that the slope was 0, but that was y equals for a flat line. Now for a straight up and down line, vertical, we get just x equals the value that that line is at. And we'll talk more about those in those special cases as we move on through our graphing unit. Thanks for listening. Have a great day. Bye-bye.